Good morning, geometry students. Welcome to class today on Tuesday, the 8th. Hope you guys are ready to learn some math today. Hope you're doing well. Jasa, looking forward to the senior night this Friday. Hope you guys play well. And I hope you guys are ready for your quiz that we're going to have this Friday. So be paying attention this week. Oh, and by the way, speaking of quizzes and tests, I want to be a little negative and a little positive, okay? First of all, now maybe you guys delegated a zoo to be the one to tell me, and if that's the case, then I apologize for getting on to you guys. Maybe you guys all agreed, or maybe she said, hey, I'll email Mr. Earhart, but if you guys did not agree to that, I should have had 4 emails from you guys telling me, hey, Mr. Harmon was not in class today, so we did not get our tests. I went over all of these guidelines at the start of the year, where I said, if class does not go the way it's supposed to go, it is your job to contact me and tell me, okay? Now, again, I could see you guys saying, or I could see a zoo speaking up and saying, hey, I'll email Mr. Hart and let him know. And if so, that's fine. But if that didn't happen, I should have had 4 emails. Now, students, it is your job to let me know what's going on. So, anyways, someone should have contacted me there. And one person did, and that's fine, but maybe it should have been more. I'm not sure. If you want, I'm not going to go over the test again. If you want to go back and watch that video again, it's right there in your account. You're welcome to do that on your free time. You can do it from home if you want to. But if you want your tests and you want to know how you did on your tests, whoever's in the classroom today, whether it be Mr. Harmon or not, just let them know that your tests are in Mr. Harmon's box in a yellow folder, and he can pass those out to you. Okay? All right. And the positive is everyone's caught up and y'all are doing well, and I appreciate that. And let's continue the good work. There will be a quiz this Friday, so make sure you're ready for that. We'll go over what's going to be on that quiz more in detail this Thursday. You do owe me homework, so would you please turn it in now? Please get out your homework now at this time and turn it in. Unless you turned it in yesterday, then that's fine, okay? So please turn in your homework at this time. All right? Okay, grab your notebooks, grab your books, grab your pens, pencils, calculators, all of those mathematical devices you need, and let's get started. Here we go. You do not need to write this down. I'm just going to ramble. I'll let you know when you need to write something down. We're going to be looking today at 2 theorems and 1 corollary. Let me grab a drink of water here. The reason I tell you that is so you know how much math we're going to cover. It kind of helps you pay attention a little more so you know how much teaching is going to go on. And I also want you to know what we're doing today. We're going to look at 2 theorems and 1 corollary. Now, you might be wondering, what is a corollary, right? I mean, we've looked at theorems. We've looked at definitions. My computer's acting really weird, guys, so if it shuts down or something, we'll just have to go from there. My pen is not working well. We've looked at theorems, definitions, postulates, and now we are going to start using, that's a typo right there. I'm going to fix that while I'm talking to you guys. And now we're going to start using corollaries, okay? Thank you for your patience. Appreciate that. So we've looked at theorems, definitions, and postulates. Now we're going to start using corollaries. Okay? Now, what is a corollary? Well, you don't need to write this down unless you want to. If you'll notice here, I am not going to quiz or test you on this definition. A corollary is a statement that relates to a certain theorem and can be proven easily. So it's really basically almost like a postulate. A corollary is a statement of truth, something we know to be true, and it relates to a certain theorem. Now, postulates, we don't prove those, we just accept those to be true. But a corollary, we can prove those, and they're usually proven pretty easily, and it's a statement that relates to a certain theorem, okay? And that's all that a corollary is. So here we go. With that in mind, let's go ahead and get started. I do want you to write this down. This is very, very important, okay? Theorem 4.1. The sum of the measures of the angles of a triangle is 180 degrees. We've talked about this before, students. You know this. The sum of the measures of the angles of a triangle is 180 degrees. Now, I'd like to show you a couple examples here, and I'd like you to write these in your notes. And you need to copy this theorem in your notes, of course. But I'm going to go ahead and draw a triangle. I'd like you guys to copy that triangle down. And let's go ahead and, in this triangle, let's write some angles. We're going to call this 40 degrees right here. And this angle here is about 90. We're going to call it 95. And then we're going to call this x. Actually, we're not going to call it x. We're going to call it 45, 40 degrees. Let's see. 135, 40. We'll call this 45 degrees. Now, watch this carefully. If you take all three of these interior angles of a triangle and you add them up, 40 plus 45 plus 95, 0, carrier 1, 5, 9, 18, you will get 180 degrees. And that is what this theorem is saying. So with that in mind, guys, if you don't know an angle inside of a triangle like that, wouldn't it be really easy to find that angle? Just add those two angles together right there. And when you add these two angles together, you get 135. So subtract that from 180, and you know you're left with 45 degrees. Okay? So that's the main idea of this theorem is for you to understand that all three angles inside of a triangle do add up to 180 degrees. We can use that to solve some math problems. For example, I would like you to write this problem in your notes, please. For example, copy this down. Quickly copy this down. Let's find the measure of the missing angle. We'll call it x. Well, look, students, from now on the rest of the year, anytime you know two angles within a triangle, you can easily find the third angle. First of all, take your two known angles and add them together. So 43 degrees plus 85 degrees would be 128. And now subtract that from 180. And again, sorry, my computer's really freezing up, so the pen's not working well. You will get 52 degrees. So this missing angle right here would be 52 degrees. And you know how you can check that? If you add all these angles together, all three of them, you will get 180 degrees. So that's really, really, really a basic theorem. And you know my philosophy. My philosophy is to teach quickly, give you time to work on your homework in class. I hope that you finish it in class. And if you don't, hopefully you get most of it done and you can finish it at night. If I don't need to teach for a long time, I'm not going to. And this is really a basic theorem. The sum of the measures of the angles of a triangle is 180 degrees. Now I want you to write down a corollary. Now this is called a corollary to, I'm going to cross this off. I don't like this. It's called a corollary to Theorem 4.1. Okay? Corollary to Theorem 4.1. So the theorem that we just learned, this is a corollary that goes along with that theorem. And again, it's not that I can't write. My pen is freezing up a lot on me here tonight. So there we go. Corollary to Theorem 4.1. Write this down, please. Corollary to Theorem 4.1. You need to know this. You'll be quizzed on this and tested on this with fill in the blanks. The acute angles of a right triangle are complementary. Now really this is common sense, students, but still, let's go ahead and take a look at this. And when I say common sense, here's what I mean. Look, go ahead and draw a right triangle in your notes, would you please? And label this angle your right angle. And we're going to call this 35 degrees. Now listen to me. I just taught you how to find a missing angle, right? Sure I did. You would take 35 plus 90, add them together, and subtract from 180 because you know all three angles have to add up to 180. But here's what this theorem is saying. This theorem is saying you don't have to do all of that. Whenever you have a right triangle, and we do have a right triangle, then these two angles right here, here's our right angle, this angle right here, and this angle right here, they are what? Complementary. Now doesn't that make sense? Come on students, think about this. If you took this angle here and this angle here and add them together, you would have to get 90 because what is this angle right here? 90. So these two together add up to 90. This angle is 90 and 90 plus 90 is 180. It makes total sense. So whenever you have a right triangle, here's your right angle within a right triangle, these two angles here will always be complementary, or in other words, these two angles here will always add up to 90 degrees, these two right here, because we already have how much over here, students? 90 degrees. So these two here together will always have to add up to 90 degrees, these two angles here, as long as you have a right triangle. All right? Okay, let's continue on. Now, you're welcome to turn your books if you want to, page 180, example number 2, or you can just copy this in your notes, whatever you want to do, okay? Now, my advice to you, we're going to look for the measure of angle DAB and the measure of angle BCD, and we're going to apply that last theorem. But can I show you something real quick that I think you probably need to see? I think it'd be easier if we copied our two triangles away from each other. I'm going to trace over this triangle here like that, and then I'm going to slide this out. And watch what I'm doing here. Just watch carefully, okay? I'm going to pull this out of the way. It's best sometimes, students, please listen to me, when you have a triangle within a triangle, sometimes it helps to write the two triangles separately, like I'm doing now. There. And I think you're going to see that makes the problem a lot easier. Now watch what I do. Please watch. See this right angle right here? See that? Okay, I'm going to put that right here. And see this right angle right here for angle B? I'm going to put that right here. And then we have an A here, a B right here, a D here. This would still be A. This would still be B. And this would still be C. Do you see what I've done there? I'm telling you, students, it makes it so much easier when you have a triangle within a triangle to split them up. Now, you're probably saying, Mr. Earhart, why didn't you worry about this triangle right here? Well, we might need to. Maybe I made a mistake. We'll see in a second, but I don't think we need to. But if we do, it's no big deal. We'll just draw that triangle off to the side, so it's no big deal. All right, we're going to find, first of all, the measure of angle DAB. The measure of angle DAB. And also we're looking for the measure of angle BCD, okay? BCD. Now, I started to work this out, and if you notice, I paused the video. I was like, you know what? We really can't do this. I'm kind of laughing at myself. We don't have enough information, so I apologize to you. There's one other thing they gave you that I forgot to write down. Here it is right here. And I was looking in the book, and I was like, man, this problem is impossible. So I looked in the book at page 180, and maybe you saw this already. They actually give us the measure of angle ABD. The measure of angle ABD equals 35 degrees. Okay, now that's a lot better. Okay, all right, here we go. So let's go ahead and put 35 degrees right here. That's angle. Wow, my pen is really messing up. I know you're getting tired of hearing that, but I don't know what to do. It's just not working very well. Okay, 35 degrees. Okay, now we're going to find, first of all, the measure of angle, look, DAB. 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 Well, do we not have a right triangle? Yes, we do. And what did we just learn about right triangles? Whenever you have a right triangle, these two other angles here always add up to 90. So if that's 35 degrees right there, then simply take 90 degrees and minus 35, and you will get 55 degrees. So we know this angle here has to be 55 degrees. We know that because 55 plus 35 is 90, and 90 plus 90 is 180. So the measure of angle DAB would be 55 degrees. Now watch this, scholars. See this angle right here? 55 degrees right here? Well, students, doesn't that mean also I could put 55 degrees right here? Isn't that the exact same angle? You know it is. Sure it is. So now the other angle they want us to find is angle BCD. 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 This angle right here. Right here. Well, look, don't we have a right triangle? Here's my right angle right here. We have a right triangle, correct? Sure. So if we have a right triangle, that means this angle here and this angle here are complementary. They add up to 90. So I'm simply going to take 90 and subtract 55 degrees. And again, I can write, my pen is totally freezing up, 90 minus 55 degrees, and you'll get 35 degrees. Okay, I'm going to have to go ahead and pause the video and try to fix this computer. Okay, I'm back. Hopefully this will work a little better. All right, and if not, then it doesn't. Okay, so 90 minus 55 is 35 degrees. So that means this angle right here has to be 35 degrees. So 55 plus 35 is 90, plus 90 is 180. We know this has to be 35 degrees. Look, if you don't like this corollary about these two angles here adding up to 90, and you want to do the whole thing where you add them all up and subtract from 180, that's totally fine. I don't care. But this corollary right here is just a shortcut. The acute angles of a right triangle will always add up to 90. The two acute angles of a right triangle are complementary. They will always add up to 90. Okay? Now, I'd like to give you a chance to earn some bonus points. You're welcome to use the preview. And by the way, let me stop right there. You might not need any bonus points. That doesn't mean you skip these, okay? Absolutely not. And you probably don't need bonus points. I think I offered you, I think 3 yesterday. You had 3 last Wednesday from doing your homework assignment, so you probably don't need it. The most you can have is 5 anyways, and after you take a quiz, I make you empty out your bonus point account. So really, that's up to you, but either way, we're going to do these. So if you need the bonus points, fine. If you don't, that's fine. We're still going to do these. But I want you to turn to page 180 and do the 3 at the bottom of the page, okay? Read the directions, do those, and then when you're all done doing all 3, please turn the video back on and listen as I work these out, and make sure you got these right. Okay, go ahead and do that now at this time. Okay, hopefully you did well on these. Here we go. Let's take a look at this number here, number 1. We're going to find the measure of angle A, this angle right here. Well, notice we have 2 angles, one that's 65 and one that's 50. So 65 plus 50 is 115, and then subtract that from 180. And you will get 65 degrees. I hope you got that right. The measure of angle A is 65 degrees. If you add all 3 of those angles together, you will get 180. All right, let's move on now to number 2. Okay, we have 2 angles here they've given to us, 45 and 60. Add those together and you'll get 105. And now subtract 105 from 180. And you will get 75 degrees. So this angle right here, B, is 75 degrees. And now let's take a look at this last problem here. It's a little more difficult than the other one, so let's see if we can't figure this out. Find the measure of angle C. Now, I would first of all, I know in the last problem I split the triangle up. I'm going to do a little shortcut here, and I probably shouldn't, but I would like to draw all of your attention to this little triangle. Would you please just ignore this right here? Just ignore this for a second, would you please? Thank you. Just look at this little triangle here, triangle ADE. Now, we know this is 90. Do you see that? We know we have a right triangle, so that means your other 2 angles add up to 90. We know that. That's a corollary that we just learned. So watch what I do here. I know that this angle right here has to equal 40 degrees. Okay, do you see that? 40, 50, and 90. So I'm going to erase all this now. And what I'm going to do, hopefully you saw that okay, I'm going to squeeze a 40 in here. Okay? Now, what I'd like to do next is I would like you somehow to just kind of forget about this line right here. Just forget about this. And now focus all of your attention on the big triangle, this triangle right here that I'm outlining in blue. There, there, and there. Okay? Now watch carefully. They want us to find the measure of angle C. Well, this is easy, guys. This big triangle right here is a right triangle. We have a 90-degree angle right here. So we know this angle here, 40 degrees, and this angle here have to add up to 90. So the measure of angle C would have to be 50 degrees, okay? Because if you put a 50 right here, look students, 50 plus 40 is 90, plus 90 is 180, so the answer is 50. I hope you did okay on those for your bonus points. Okay, let's continue on. Now we need to take a minute and talk about interior and exterior angles. I'm not going to give you definitions, but you definitely need to know what these angles are. So in your notes, if you would, please kind of draw a triangle like this. That's good enough, doesn't really matter. And I want you to know, put a 1 right here, put a 2 right here, and put a 3 right here. And then down below I want you to write angles 1, 2, and 3 are interior angles of a triangle. Now that's pretty obvious, okay? That's not really a surprise. I mean, interior means on the inside. Angles 1, 2, and 3 are interior angles of a triangle. Okay, I'm going to erase this in a second. That's pretty much common sense. Write that down if you would. Now I'm going to erase this. Angles 1, 2, and 3 are interior angles of a triangle. But now here's where it gets interesting. Exterior angles is something that students seem to get really confused on. And if you'll just listen to me, I'll explain this pretty well, okay? An exterior angle of a triangle is when you put your pencil on one side. Go ahead and put your pencil on this side here and just kind of trace it. And then as you trace, go like this. Go, whoops, and go too far. And that's totally fine. All right? Now, you don't have to say whoops if you don't want to, but put your pencil on a side and then just extend that side. And then stop. I don't know why students get so confused. They do stuff like this. They extend two sides like that. Or they draw a, I don't know, they draw a smiley face in the middle. I'm just kidding. They do all kinds of stuff. An exterior angle is when you simply do this. You take one side of a triangle and you extend it. Isn't that easy? So this angle right here, would be an exterior angle. We'll call it 4. 4 is an exterior angle. Well, Mr. Earhart, what if I extended the other side? No big deal. Go ahead, knock yourself out. I'm going to extend this side. Okay, fine. So now this would be an exterior angle. It's this simple, students. Every time you extend any side of a triangle, you get an exterior angle. Just don't do this. Don't extend two sides like this and then call this here an exterior angle. No, you extend one side and one side only, and that is an exterior angle. So I could come down here, draw this, take this side here and extend it, and this is an exterior angle right here. That's an exterior angle. Or I could extend this side. I could trace this side right here and extend that side, and this would be my exterior angle. Anytime you extend one side of a triangle, you get an exterior angle. We could extend this side like this. There's an exterior angle right there. Now, it's so important you understand that. And the reason is we're going to look at a theorem here in a second. In fact, here it is. And this theorem deals with exterior angles. So go ahead and copy this down. This is called Theorem 4.2, the exterior angle theorem. And here's what it says. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Let me show you what that means, okay? Go ahead and copy this down. I'm going to grab a drink of water here. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Here's what that means. Would you please take some really good notes on this? Go ahead and draw a triangle. It looks something like that. That's totally fine. And I want you to come inside here and I want you to label your angles 1, 2, and 3. That's easy enough. And now take your pencil and I want you to extend this side right here. Okay. So now we're going to call this angle 4. So you do recognize angle 4, don't you, students? Angle 4 would be an exterior angle. That's what we just talked about a couple minutes ago. Angle 4 would be an exterior angle. So 1, 2, and 3 are interior angles, and 4 is an exterior angle. Now, the theorem says this. The measure of an exterior angle, the measure of this angle right here, watch this, the measure of this angle right here is equal to the sum. That means you're going to add the sum of the measures of the two remote interior angles. Now, Mr. Earhart, what's the two remote interior angles? Well, I'm glad you asked. If this is your exterior angle here, then your two remote interior angles are these two angles over here that are way far away from this exterior angle. It would not be this angle right here. Okay? Do you see that okay? Let me show you another example. Watch this carefully, please. Let's say I extended this side here. Now watch. Let's say I extended this side, and we'll call this angle 5. Now angle 5 is an exterior angle. What two angles would you add together to get the answer or the measure of angle 5? Well, it wouldn't be angle 2. Remember, it's the two remote, that means far away, remote interior angles. So if this is your exterior angle, then you would add these two angles together, and that would give you the measure of angle 5. Isn't that really cool? I think it's really, Really cool. Let me give you one more example. Let's say I extended this side right here. We'll call that exterior angle 6. Now, what two angles would I add together to get the measure? What two angles would I add together to get the measure of this exterior angle? Well, it wouldn't be this angle here. It's the two remote interior angles, so I would add 2 and 3 together, the measure of those angles, and that would give me the measure of this angle. Isn't that cool? So anytime you have an exterior angle of a triangle, it's equal to the sum of the measures of the two remote interior angles. That's what that theorem is saying. Let's practice this with some math problems. Would you go ahead and copy this in your notes, please? Go ahead and copy this in your notes. Now, while you're copying this down, listen to me. I want us to find the measure of angle 1. The measure of angle 1. Now look, angle 1 is obviously an exterior angle, is it not? Here's your triangle right here, and you took this side and you extended it. You went straight out, and you put a 1 here. So angle 1 is definitely an exterior angle. Now, how do you find the measure of angle 1? Well, you don't use the angle that's close to it. You use the two inside angles that are furthest away from the exterior angle, and you add them together. That's all that you do. So 58 plus 72 would be 130 degrees. So what is the measure of angle 1? The measure of angle 1 equals 130 degrees. Okay? Pretty cool. Now, I know that you're probably not needing any bonus points, and that's fine. Just do this because I'm telling you to. If you want the bonus points, fine. If you're still struggling and you don't have 5 in your account yet, then go ahead and give yourself a half a point for each one you get right. But I want you to go ahead and pause the video, turn to page 181, turn to the bottom of the page, and I'd like you to try these 3 on your own, okay? And actually, we can all kind of laugh here at Mr. Earhart's senility here as I'm getting old and senile. I guess the answers are right there. Anyways, there we go. Go ahead and work on these 3 problems, and then when you're all done, restart the video and let's see how you did. Okay, hopefully you did well on this project here, or these problems. Let's see how you did. Let's start with number 4. I want you to find the measure of angle 2. Now, angle 2 is an exterior angle. So when you go to find the measure of an exterior angle, you do not use this angle next to it. You use the two inside angles that are far away, and you add them together. So 60 plus 60 would be 120 degrees. So the measure of angle 2 would be 120 degrees. Now let's come along to number 5, and let's find the measure of angle 3. Now, angle 3 is obviously an exterior angle. You extended one side right here, and so we definitely have an exterior angle. Now, how do you find the measure of an exterior angle? Well, you do not use the angle that's right next to it. You use the two inside angles that are furthest away from this exterior angle, and you add them together. So we have 125 plus 30. The measure of angle 3 would be 155 degrees. Now, same thing over here. We have an angle 4 right here, and obviously it's an exterior angle. You took this side right here and you extended it, so we definitely have an exterior angle. And when you go to find the measure of an exterior angle, you do not use the angle that's closest to it. You use these two angles over here, these two remote interior angles, and you add them together. So 58 plus 55 would be 113 degrees. So the measure of angle 4 is 113 degrees. Okay? 113. So half a point for each one that you got right. I hope that was a help to you. Now, I want you to go ahead and get started. This is due tomorrow. Okay, you might have to take some of it home. The video's been a little longer than usual. That's not going to kill you. That's fine. Go ahead and turn to page 182, excuse me. Let's start working on numbers 6 through 21. Do that until the bell rings, please. You'll definitely be challenged on numbers 18 through 21. See how you do on those. Maybe you can get those. That'd be really cool if you could figure those out on your own. Those can be somewhat challenging. So if you need help on those, remember there is a homework video you can watch if you need to. So page 182, numbers 6 through 21. I hope you guys have a great rest of the day. Please continue to work hard. Call me or email me if you have any questions.